Yeah, now I've got audio. How we doing? How are we all doing? Happy New Year to everybody. I don't know if you spotted the obvious mistake on the credits because that still says 2020. So not sure what's going on there. But unfortunately, I haven't had time to do anything to that this morning. But I will do. I will do. I think we've had a few disappear off the top, I believe, because there was, I think, Mr. Mike Atlantis was up there and various other people. But once again, YouTube's chopped off the top of my chatlet. Never mind. So we all had a great Christmas, everybody, and we're looking forward to the start of this year. Mine's a disaster, but I'll tell you about that in a minute. Oh dear, oh dear. I nearly didn't come on today. I only just made it on, so there you go. I can't disappoint all my viewers. Afternoon, Daniel. Daniel's in. Happy New Year to you as well, mate. And Harp, Happy New Year, Harp, and all your lab mates, I believe. Phil the Parrot, how you doing, Phil? Happy New Year to you as well, mate. And to Chris, Happy New Year to you. 4,000 subscribers. Yes, I think it was 4,017 this morning when I checked. So that's a brilliant achievement. I'm really, really chuffed with that. So thank you to all my new subscribers that jumped in over the Christmas period and helped me get to that 4,000 mark. Onwards and upwards to 5,000 now. We're going to get to 5,000 by next Christmas. You never know. You never know. Chris is looking forward to the 2022 live streams. Yeah. Yeah, me too. I've got lots planned still. A few tweaks. Michael Hyde, how are you doing, Michael? Happy New Year to you. And to Rob, Happy New Year to you, Rob Cross. And Simon's World, hi Simon. Barry, afternoon, Barry. Happy New Year to you. And to Rob, Happy New Year. Timothy, Happy New Year. Hello, Benji's in. Nick's in. Luigi, Happy New Year to you, Luigi. Aston, afternoon, Aston. Happy New Year to you as well. May your aerials be straight and your AF117s be tin whisker free. I wish. Oh dear. You got knocked off the top, Anthony. Sorry about that, mate. Gotta love a bit of YouTube knocking off the top of me. Good afternoon, mate, anyway. And Happy New Year to you. Dave Rhodes. Happy New Year to you as well, Dave. May you have as happy as a Pfizer shareholder. I wish. No shares in that, unfortunately. Happy New Year, Chris. Afternoon, Mac Vision 3D. So yes, my morning. So started the morning off quite nicely. Just sorting out a slide for today's show. Sorting out what I was going to do first, really. And then as I was doing that, Chris's premiere came on. So I hope you all caught Chris's premiere this morning. Very good. I didn't catch it all. And this is where the story starts, really. So I was up here tinkering around with YouTube. I was going to sort out some new credits and all the rest of it, and sort out my Patreon list because I've got a new Patreon. So welcome to all my Patreons. Thanks again for your support last year and into the future. Anyway, I was going to do all that, and I had a shout from Mrs. Cruncher saying the dishwasher's not working. So I said bye to Chris and everyone else on this stream, well, on Chris's premiere, and went down to find out what the problem was. Anyway, turns out, this is a long story, by the way, so you best if you want to go and get a coffee now. I'm Maru Ganesh and Patrick B. Happy New Year to you as well, mate, both of you. So anyway, went downstairs and the dishwasher's got a fault code on it, H. H? What on earth could H mean? Looked in the book, absolutely no fault codes at all. Went online, again, no H fault code whatsoever. So I thought, what the hell is H? So I thought perhaps it's the heater. Maybe the heater's pattern. This is 2 years old in a couple of weeks' time. So it's not even 2 years old, this dishwasher. It's an Indeset. So I thought, well, I'll pull the drain and that off of it. So pulled all the drain pipes off, drained it into a bucket, and yeah, that was all clear. fired it through, tried to fire it up, and it was draining out fine, no problems there. So I'll have to ring Indicet. So I rung up Indicet's helpline, and they're 365 days a year, so rung them up. He said, it sounds like it's a water supply issue. I thought, well, it's drawing water in. I can hear it drawing water in, and I'm able to drain water out of it, so it can't really be that. He said it could be a kinked or a blocked pipe, so I thought, well, potentially it could be a bit of muck got into one of the little gauze filters that they fit in the end of the pipes. So I thought, well, I'll whip the connection off and have a look at that. And pulled that off, and dead clear, no problem at all. So there's no way that debris would have got through that first filter and through the second filter to stop the machine working. So it wasn't going to be that. But I thought I'd take the plinth off the bottom of the worktops, and this is where it gets the kitchen work units, the base units. I thought I'd take the front plinth off, which is where this is getting going to get very nasty now. And anyway, just a bit of back history. For a few weeks now, we've been smelling sort of dirty dishwater smell. I don't know if any of you have got caravans or anything like that, and the dishwater, like when you undo a waste pipe underneath a sink, that sort of horrible old stagnant water smell. We've had that for a while. We thought it was just dirty pipes, so we've been putting this dishwasher cleaner and what's the other, washing machine cleaner through to clear it out, and that sort of worked, but then it came back quite quick. So we thought, well, obviously we need to do it again, and we hadn't really got around to getting some more of this stuff. Anyway, took this bottom plinth off, and it's absolutely stinking under there of like dirty dishwater. Horrible smell, really nasty smell. So I thought, that's not good. I only pulled the plinth off to look at where the water pipe went up to the dishwasher. That was the intention. So anyway, I pulled the plinth off, and I've got one of these inspection cameras, you know, with a little gooseneck and I don't know what you call it, like an endoscope, I suppose. I've got one of those. I thought, well, this looks a bit strange. So I poked that in through the chipboard, and we have got standing water underneath the chipboard in the house. the reason why, well, obviously we've got a damaged waste pipe somewhere between the kitchen and the soil stack in the hallway. But the problem is we've got a floating floor. This is not a normal floor. We haven't got floorboards. We've got a concrete base to the house. Then there's usually about 2 inches of polystyrene, and then on top of that is chipboard. So we've got like a 2-inch gap between the concrete and the chipboard, which is filled up with polystyrene, just polystyrene sheets. So what's happened is we've got a pipe has leaked in this polystyrene somewhere, and it's been leaking for some time. It absolutely stinks in there, and it's gone and it's filled. I think it's potentially filled up the whole of the downstairs floor with dirty dishwater. Sort of water from the dishwasher, water from the washing machine, water from the sink has all gone down and flooded the whole of the understairs floor. So the whole of our understairs is potentially underwater. It's an absolute nightmare. And it also, for various reasons, it turns out we're not insured either, which is even greater. You know, what a great start to the year for me. So God only knows what we're going to do. I've just come off the phone to my brother. He's a builder, and he's sort of given me a couple things to try, which I sort of already had in mind anyway. But I really don't know where to go next with it, to be honest. I mean, not only have we got a knackered dishwasher, but we've potentially got we've got a complete floating floor that needs to come up and be replaced for the whole of the downstairs, because it's literally, they just put polystyrene all over the floor, and then they chipboard it and glue it all together. So the chipboard is, you can't just cut bits out of it because it makes the floor unstable. Absolute nightmare. Absolute nightmare. So I don't know where to go next. I don't really know any builders. I haven't got the money to fix it. So I don't know what to do. I just do not know what to do. It's an absolute disaster. But there you go. These things happen, don't they? The joys of owning a house. So there you go, that's my little story for today. If you didn't get all that, I'm not going to repeat it, so you'll have to play the video back. Who else have we got then? Hi, Colin's in. ZX Harvey's there. Afternoon, Harvey. Happy New Year to you both. Les is in. Hi, Les. Happy New Year to you as well, mate. Simon. How you doing, Simon? Yeah, I certainly need some help, mate. And we've still got ho, ho, ho up here. Mrs. Cruncher's taking the decorations down at the moment, but we haven't had time to do it. Yeah, great start, Simon, isn't it? It is an absolute nightmare. Can you pump water out and use a dehumidifier? You can't, Nick, because if you think about it, the polystyrene is sat directly on the concrete. There's no gap. And then between the polystyrene and the chipboard sits on the polystyrene. So the polystyrene in between the chipboard is saturated all throughout. I mean, it should be waterproof flooring. You know, it should have a waterproof coating on it because it's a fairly modern house. So, you know, the only idea I've got at the moment, I've got to take the kitchen out tomorrow. So I would have done it today, really, but I wanted to come on and say Happy New Year to you all anyway. I don't know if I can face doing it today. So basically, we've got to take the kitchen unit out. I've then somehow got to cut an access hole in this floor underneath the kitchen worktop, because I can't take the worktop out as well, I don't think. I've got to take... I might be able to get the worktop out, I don't know. I don't know. It's a disaster, but I basically got to get the sink unit out. So I've got to disconnect all the pipework for the sink, get all that pulled out. I've got to pull the dishwasher out. I've got to pull the washing machine out. I've got to cut a hole in the floor and get a piece of chipboard out and just have a look and see what the extent of the damage is. And the problem is I've got a frozen shoulder, so I can't really work. I don't know. It's just an absolute disaster. It is a disaster. Mrs. Cruncher's upset about it as well, but there you go. What can you do, everybody, eh? What can you do? There's no point crying about it, because it won't get it done. It won't get it done. So let me catch up with the chat. Anyway, that's my little sob story for the start of the new year. So apologies for that, people. Hopefully that hasn't got any of you down. We've got plenty of radios to fix anyway. Joe Santo. Afternoon, Joe. Massive sponge. Yeah, we got a massive sponge. It's called polystyrene. Yeah, I know, Les. Get a bilge pump to get the water out. You can't, Simon. It's not. I don't think you can dip it into it. It's sort of. I think it's just spread the complete downstairs. I don't know. So someone drove into Aston's Mini yesterday. Sorry to hear that, Aston. God dear. Oh, Marky, how are you? I know. I can't pump it out. I mean, all I can do is get dehumidifiers in and try and suck it out that way. Assuming that I can get an access. The problem is because the chipboard is mounted on the polystyrene. As soon as you cut a piece of chipboard out, it's got nothing to bite to. You can't refix it and make it structural again because you've cut a piece out of it. So I'm just going to have to be very careful and just cut to the edge, really. But yeah, I've got to patch another piece in. I know we had problems many years ago when I was the manager for British Gas, basically, and I was a manager, a quality assurance manager, and we had one of our lovely contract engineers decided he was going to run all the pipe work downstairs underneath the floating floor. So he cut traps all the way around this floating floor, lifted it up, pulled all the polystyrene out of the way, put his pipes in, and just dropped it back in again. And of course, it's got nothing to hold to, so the floor was moving all over the place. And we ended up having to move these people out into accommodation and basically replace, excuse me, replace the whole floating floor throughout. So yeah, that's I just hope it doesn't come to that. because you know it's got a fairly big floor area downstairs. Excuse me. Sorry, I'm not well enough. It's I've just had I've been trying to eat my dinner as well because I've just come off a phone to my brother and I haven't had a chance to eat or nothing yet. Thank you very much, Rob. The floor fund. We need the floor fund. Yeah, so yeah, floating floor is an absolute nightmare. If it's floorboards, absolutely no problem at all. Just take a trap up, get in underneath, sort it all out, put it back together, and away you go. But modern construction, all this insulation and rubbish, you know, it's not good for DIY, is it, at all? So yeah, it's a bit gutting, Aston, isn't it? But there you are. That's my dilemma. I have not sewage water, but I have grey water, as they call it, underneath my whole downstairs floor that I can't get out. But anyway, I will be pulling the sink unit out tomorrow, and we'll see. We'll see. I shall update you. I shall update you in the community tab and let you know how it's going. I'll see if I can take some photos and that as well while I'm at it. Give you an idea of what's happening. But yeah, as I say, I poked the end of this endoscope in. It's got lights on it, and I could see this film, and the film was rippling. And I touched this film with the tip of the endoscope, and of course it moved away, and it was water. So we got water sat under the floor, basically. Happy New Year to you, Richard Achilles. So yeah. Anyway, the joys of it all. The joys of it all. But we got a radio to have a play with today, anyway. We got a radio to have a play with, and we're back to the Hacker Mini Herald, which you've all seen. And we've played with this before. But yeah, sorry to start a stream like that, but I thought I'd explain why I'm a little bit sort of unprepared today, because that's obviously taken some time. It could do with more time, to be fair, but I don't think I'm going to achieve anything by ripping the kitchen apart right now. At least tomorrow, get up early. I'll get a good run at it. So we can't use our washing machine, dishwasher, or the kitchen sink at the moment. So any washing's got to be done with a bucket underneath the sink, or in one of our toilets. Basically, we've got basins in the toilets that we can use. That's it. I can't use any other water systems in the house. Anyway, that's enough of that. Shut up, Graham. Happy New Year, everybody, anyway. And thanks again for getting me to 4,000 subs and for all your help and support through all the Christmas live streams. As I say, I've still got stuff to post off, people. I've still got stuff to post off. I haven't done any posting yet. I basically had last week off, pretty much. So after the Christmas, that was it. I had a bit of a shutdown. Me and Mrs. Cruncher had some time together, which was nice. And say we had the grandchildren up yesterday, most of them, 3 out of the 4, and my son and daughter-in-law came over. So that was our day yesterday. And Mrs. Cruncher's just down taking the decorations down, which is a shame because we like the decorations. I say I've still got them up here. They're still up here everywhere. Now, is it me or is the live chat stopped? VP, afternoon, Valdir. Happy New Year to you as well, mate. Sorry I didn't see you in there. Yeah, Les, you have to bring your overalls out, Les, next week. Yes, thank you very much, Rob. So the idea today, I think we've done a lot to this radio already. We've done all of the RF and IF board. That's all been recapped. We put new AF127s in there. That's good to go, apart from maybe an alignment, but we'll see about that. So today's job is going to be this amplifier board. Now, I've done nothing to the amp board at all. So nothing at all to the amp board. So that's got to come out. It's got to have the caps replaced in it. and we've got one of these, what do you call them, a bipolar cap in there, or reversible cap as they called it back in the day of this thing. So we've got to get that out and replaced, and then we've got to try and mess about with these horrible variable resistors, variable wire wound resistors. Yeah, you'll soon catch up, Chris. You're getting subs a hell of a lot quicker than I ever did, mate. So you know, your content's very good, Chris, and you spend a lot of time and effort making it. So you know, it will come. It will come for sure. So this is those lovely wire wound resistors, and we got a bit too much light on the subject again. There you go. So basically we've got RV2, and I think there's RV1 is in the back here. You can't quite see that, but there is two in there. One's for the midpoint voltage and one is for the current, I think, or is it current for each pair? I can't remember. This is a little bit different, this radio, than the other ones. Let's go in a bit closer. Am I? Yeah, I think so, yeah. So yeah, this is a wire wound resistor, and you've got this little cradle that slides up and down on it. It's a little slide with a bent piece there, and you basically adjust that. There's a little link to cut in behind there. You can just about see the top of that where my screwdriver is, can you? No, you can't. It's just at a weird angle. If I go sort of down like that and then in like that, you'll sort of see it just poking up behind there, look. So that's the link that you've got to cut there to do the measurements. So that's the plan for today, is to get this board fully recapped. Well, there's not that many caps in it, to be honest, so it ain't going to take us that long, and then we can start doing some, we can set it up and maybe look at doing an alignment if we've got time. But, I'm not going to be on for a massive amount of time today because I've really got to make some phone calls and see if I can get some help. So lots of messages and that coming through here, but I've got to ignore those for now. So that's the plan for today anyway. Happy New Year, Paul. How are you, mate? George, you're up at 3.5k. Bloody hell, George. Well done, mate. What's happened to the floor? You'll have to play it back, Paul. You'll have to do a rewind later on. It's too depressing to keep mentioning it. Right, let's get in a bit closer. You basically got a bit of a flood under the floor, mate. Bit of dirty water. So let's just pop this top section out of the way. So I haven't screwed it in, I've just slid it in there for safety. There was lots of other things I was thinking about doing today, but I did think let's just crack on and get something finished. Right, let's just disconnect this, get the case out of the way then. Just pop those back on for now. So I know where they are. And get the amp sorted. So apologies, I'm going to still be doing a bit of eating of my lunch as we go on. I've ate the crisps, so it won't be too noisy. It's all they had, I think, back in the day, Benji. Because if I get it in on the overhead camera now. Let's get my camera sorted out. There we go. Right, it's never happy with the light, this camera. I'll have to get some sort of diffuser, I think, for it. So we've got two of these. We've got RV3 and RV2 by the looks of it. So if you remember in the hacker ones, they're small, like screwdriver turned potentiometers. But this is old school. This is 1961, I think it is, isn't it? So that's why these have got sliders. Both of these are quite bowed as well. I don't know if you can see that in the picture, but they're both quite bowed. And this is the one, if you remember, we got these white hunts. Now, I think Mr. Spanky was quite keen on those. I don't think we're going to be retaining them, but I'm trying to think if I've ever seen them before. I probably have, but not really paid any attention. But yeah, hunts, electrolytics are not normally like that. Very interesting. We've even got an old school tantalum in here by the looks of it. I think that's a tantalum. It looks like a tantalum, but it might be a poly, I don't know. I'll have to look that up just to see what value it is. It's got a value written on it, but I can't really read it. Something or other. Microfarads at 300 volts. So no, maybe it is some sort of poly cap, I don't know. So we've actually got two of these wires to cut to do the testing. It's gone dark now, isn't it? That's better. So yeah, we've got two. We've got this one here, says test, and we've also got another one over here that says test. So it looks like we've got two test points of this one. I have set one of these up before on a live stream, but it was a long time ago. But yeah, the white hunts. So nothing special, they're just 100 microfarads at 25 volts. But an interesting amp anyway. So have I got the service manual for this one here? I think I did dig it out, didn't I? RP17 Mini Herald, yeah. Okay, here we go. RP17 Mini Herald. Let's have a look at that, what that little tantalum is. What does it say? It's C4. C4, explosive. Just there, look. So a little red one there. Yeah, it'd be good to see some more videos, George. You've done well to get that without a lot of content, really. Well, you have got a lot of content, but not a lot recently, shall we say. Done well, mate. Congratulations. If you're not subscribed to Mr. Christoffi, then do it. Do it. Well worth watching. Very entertaining, George's videos. With varying degrees of hair colour. Right, so let's have a look. That's not the amplifier. Tell me we've got no amplifier information. Yeah, no circuit for that at all then. It doesn't look like we've got any information. No layout for the amp at all. Is it on the schematic? Yes, it is. So C4, no, it can't be. It's 0.003, look, according to this, so it can't be a tantalum. Yeah. But yeah, the power supply is certainly weird on this. So we've got 18 volts feeding the amplifier in a very strange way, and we've got 9 volts feeding the rest of the radio. very unusual. I think we looked at this before. So anyway, I'm going to fire up the desoldering tool, which is nice and quiet. And the other thing I'm going to do is what we always got to do is we've got to get some beer in me. So I need this today, I can tell you. So I'm going with Fat Tony's Ubu. Pure Ubu from Purity Brewing Co. Brewing? What's brewing? Oh dear. I could restuff them, yeah. So let me get this. Get me this poured out. Got a good heat on that. Got a good heat on them. Cheers, everybody. Happy New Year. First one of the... No, it's not the first one. No, I had a couple last night. Had a drop of wine last night. And obviously saw the New Year in with Mrs. Cruncher. And a bottle of fizzy. The little red caps are often way off spec, Timothy, are they really? It could well be. I mean, it's one of those things. How far do you go with it? And what does it do? Have I got these schematics on here a minute? Let me have a look. Let me see if I've got the schematics. Let's get that in shot for you. So we're looking at the little red one there. Let's see what that cap does. Big Ubu bear. What, me or the beer? Pardon me. Chris has been looking at germanium signal dials this morning. The price is going up. Was hoping for some cheap Russians, but not many out there in eBay land. What ones are you looking for, Chris, and how many? I have got a few here. I'm sure I could sort you some out. I did have something I was going to send over to you anyway to have a look at. Mike, welcome, Mike. Thanks, mate. Yeah, it is a bit of a dilemma. It's even worse when you lose your kitchen sink, isn't it? Yeah. Well, I don't know if you can see this, but in between here, we've got a rectifier alert. In fact, it's two, MR1 and MR2. See that? So we've got a metal rectifier in between, which is very strange. I mean, you get thermistors in some of them, you get diodes in some, but we've got these two metal rectifiers. Doesn't RS still stock germanium diodes? It might do. I don't know, Nick. I mean, I tend to use OA90s and AA119s, is it? I can't remember now. I haven't got a lot, actually. Is that my germaniums? Is that... No, that's 4148s. Somewhere here I've got some germanium diodes anyway. Oh, here, yeah. There we go. So I've got some. Depending on how many you need, Chris. Look, I've got a lot of these. I'm not sure if these are 1N60 or AA119s. They could be either, but I have got some of those, Chris. I think they're 1N60s. I think because they're the same as the ones in this bag, but. Saying that, there's nothing actually on them, and on my little ticket that I keep on the front, it's OA90, 1N60, OA91 or AA119, so it could be any one of those, but they're germanium anyway. So if you need a few of those, Chris, you'll have to let me know, mate, and I'll sort you some out. We'll sort you some out, Chris. Right. I was going to find the schematic for this, wasn't it? What was that, Chris? Chris says you did order some from eBay. More a warning that a lot of old stock is disappearing. Oh, right, because I see what you're saying. Yeah. Yeah, everything germanium is getting expensive now. All the transistors are ridiculous money. I must try and get some more. I mean, at the end of the day, we need them for fixing this old stuff. You can mess about and rebias stuff and try and put silicone in there, but it ain't the same. Right, let me see if I can find the... let me see if I can find the schematic for this. Oh, hello. Oh, that's... Yeah. It's not going to like this. Basically, because I had the problem with the computer slowing down, I had to delete the iCloud drive from this computer. So, of course, all my documents and everything for all the Christmas live streams were in that folder. So now I can't access it. Oh, dear. Oh, you gotta love it. You gotta love it. Right, is it in downloads? Have I downloaded this? I suspect I have. Let's search this PC for RP17. There we go, RP17 manual. I knew it would be here somewhere. Just finding it, isn't it? It's the trouble, these computers now, the drives are so big. No, we don't want edge settings, we just want the manual. Okay. So let's go to the screen cap. Let's go to the screen. Hopefully we're on the screen. Yes, we are. I'm still up in the corner. So this is the amplifier board. Can we see it from that? Do I need to go out a fraction more? Yeah, okay. So here's our output transistors. This is going to be... This is our reversible 8 microfarad coming off of the input into T1, which I think is the first AF amplifier. And so that goes off the collector into T2, which is the driver transistor, I believe. And it looks like this C4 is in parallel with R12. And that's biasing the base of T2. So I suppose if there's an issue with C4 and it's way out, that could mess that up. We've got another one here. That's the feed off to one of the is that headphone socket? Yeah, probably headphone socket there, JS1. And there's our MR1 and MR2 look, which is those metal rectifiers. Now it looks like, yeah, it looks like those it looks like they've got to be individually biased then with RV2 and RV3, so we've got a link on the supply to both of them to stick an ammeter in. So you've got to basically pull these links out, put an ammeter in, and then alter the biasing on this these two. I assume they've got to be matched identically. So no midpoint voltage setting on this, it's just bias by the looks of it. Or quiescent current setting that'll be, won't it? So yeah, C4 probably is fairly... How much influence does that have on that? Is that some sort of tone? Is that something to do with a tone? Or does a tone come in here? I'm not sure. Let's just flip up to the circuit description, because it's usually pretty good on these. Let's see what hackers say about it all. Let's get it around the right way. Yeah, so there's a description. Just get rid of me out of the corner a minute, so we can see it full screen. There we go. Okay, that's better. So let's have a look through this a minute. That's a bit of a description. It's not a great scan. This is not scanned by me. I think I got this off the Hacker Radio group originally. It says 7 transistors, 2 crystal diodes, provision for a car aerial, a tape recorder or an earpiece, several colors. So here's our transistor lineup. So this is our amplifier. So T1, as we said, was the AF amplifier, T2 is the driver, then T3 and T4 are the push-pull output stage. Now these MR1 and MR2 are stabilizing rectifiers, it says. Two PP7s, 800 milliwatts output. So here's our circuit description. So this is the front end, mixer, oscillator, IF. So we do have to align all this lot later because we've changed those transistors. So this is the bit we're concerned about here then. So this is the amplifier bit now. So we just stop moving my mouse around and that funny little bit at the top will disappear, then we can read it. So let me get my my book up with the schematic on it. I can't show you the schematic at the same time, but I'm going to read through it as it explains what it does to us. I just really want to see what this what C4 does, see if it's got an explanation of C4, which it does by the looks of it. So after demodulation, AF signals appear across VR1, which is a volume control, I believe, isn't it? Yeah, VR1 is back on the main board. That gets fed in via the plug. So they pass via C2 and R1 to the base of T1. Yep. So C2 is the bipolar capacitor. Then through resistor. So the tone correction is achieved by C3 and R3. So that's at this stage then. So that is those first two, first resistor and capacitor off of the emitter of T1 by the looks of it. So that's the tone there. So if you wanted to mess about with the tone, I suppose you could alter the values of that. But these radios sound great anyway. So the base bias for this transistor is provided from the emitter of T2 via R4. T2 by R4. Where's R4R then? R2. Oh, I see. Right. Okay, that's unusual. So that's coming straight off the... Yeah, so they're taking R4 directly off the base of T1 to bias the emitter of T2. You can see that on the schematic. Collector is the primary driver transistor. L1, the inverted signals are fed from the bifilar secondary windings on L1 to each base of the output bar. Okay, T3 and T4 operates as a single under push pull. Overall feedback is provided and presented to the base of T2 via R7, C7, R12 and C4. So this is the feedback circuit then, from the output stage. Is that right? Base bias, T3 and T4 operator cells, so the output transistors. Overall feedback is provided and presented to the base of T2 via R7. So how does that get back? I'm just looking to see how that gets back, because it looks like it just comes off pin 3. I'm not sure how that gets back. Oh, yeah, okay. They've decided not to draw the loudspeaker in on the schematic, just to really confuse me. So let's go to the schematic again. Just right down the bottom. Down there. Just flip that around. So where it says LS is normally where you'd see a picture of a loudspeaker, but we haven't got a picture of the loudspeaker, so to me that looked just like an open circuit, but it's not. It's the speaker goes in there. So our feedback is down through here, through this filter and this one up to the base of T2. So it's adjusting the gain, isn't it, of the amplifier by feeding back into here. I'm no expert on amplifier design, but yeah, it looks like it's feeding back through these two onto here. So yeah, it would affect it. I don't think it's critical though, is it? I'm not sure how critical that is, but we can measure it anyway. That's all I was getting at. Is this C4, is this critical? 0.003, and I haven't got a 0.003 anyway. I think the nearest I've got is 0047. I don't think I've got a 003. Anyway, that's our little tour of the schematic. I don't know if that's helped anybody or anybody can help me. I don't know, but there you go. Right, we've got lots of messages I've missed. £5 for 119s. Whoa. Started the first repair of 2022 with a hacker. Of course. Might as well start how we mean to go on, aren't we, Mike? Paul just wound back. Sorry to hear your bad news. If I could help, I'd be down there, no problems. Thank you very much, Paul. Much appreciated, mate. Mick McGinn, Happy New Year to you, Mick, as well. Chris has got some Russian germanium transistors before Christmas. I've not ever tried any of the Russian ones. You do have one planned. Excellent. Be good to see, Chris. You can't see them transistor things catching on. I think a lot of people said that back in the day. What's a 741, Chris? Derek, afternoon, mate. How are you? So Timothy says C4 might be to prevent oscillation by limiting response at higher frequency audio. No, got that wrong. C4 would pass, not block higher frequencies. Okay, so it's some sort of pass filter, is it, Timothy? I've got your record here, Timothy, to post off, mate. Zorba, it's coming to you soon. Coming to you soon. This week I'll be posting everything off, so anybody that won anything in the Christmas giveaways, it'll all be coming out to you this week. Afternoon, Keith, how are you? Or morning, as it is there. So, as I say, we can test C4, I mean. There isn't really any other, well, there is. We've got a, what do you call it, ceramic disc capacitor, 0.1. But apart from that, that's the only non-electrolytics in there. And this is our reversible Elka mode at 8 microfarads, which we've got to get done. So we've got Alka mode, we've got a blue Dali in behind there as well. Can you see that one? Sneaking in, we've got Alka mode, Dali, and Hunts in here. So we've got 3 different manufacturers. We've obviously got Mullard transistors, we've got an OC81D, OC71, these are getting ridiculously expensive. And can you see that the top of this OC81, let me just get that underneath the overhead camera a minute for you. Can you see there's a glass top on that? So it's transparent. Now I thought that they stopped doing that because of it causing changes to the germanium. You see it? So it's got a glass, totally clear top. So it's also like it's almost like a photo transistor. So, excuse me. Got a frog in my throat today. So yeah, unusual. Because if you look at the OC71 there, if you scraped away the paint on this, then that is also clear glass underneath the paint. I don't know if anyone's scraped one of these back, but it is just black painted glass. So I'm surprised they've left the end open on that, because I would have thought that would have affected the operation of that transistor. But then I suppose it's stuck away in a radio. It's not exactly going to get very light, is it? Yeah, unusual. You don't see many of those actually with the open end on them still. Let's just get that so you can see the marking on it. Mullard OC81D. Genuine. Hunts. There you are. So yeah, this is an Alka mode, this one, and you can see that this end is got a red filling in it, and on it it's marked reversible. So it's a bipolar capacitor, that one, and it's on the base of the first AF amplifier. You would have thought that initial one. I was saying that. No, I'm just talking a load of rubbish now. But I don't suppose it matters. That could be. I suppose that could be a polycap if you had one of the same value. But 8 microfarad would be quite high, quite hard to get in a poly, wouldn't it? Anyway, let's go back to the main screen. Yes, we did. Thank you, Derek. Hope you and your good lady did as well. Yeah, well, the record will be out to you soon. Yeah, this one hasn't got any paint on it though, Chris. This is what I'm saying. There is no paint on this one, but there is on the OC71. Normally the OC81Ds are in a metal can. I've got some here, I think. 81Ds. Yeah, I've got some OC81Ds here, I think. Yeah. That's 81s. 81s. OC81Ds are like rock on horse poo. I've got 81s, but I've got a few 81Ds, but not a lot. I have a few. So that's a normal OC81D in a metal can. It's unusual to see one not in a can and not with a load of paint over it. So yeah, that's a normal OC81D. Sometimes you can pull them and the actual inside piece will come out. If I've got one like that here that I can give a yank to, that will just come out. No, I haven't. Oh, actually, no, there's just a top there, so where's the bottom of that one? No, I must have slung that one. Oh well. Anyway, there you are. So I assume that cap, all it is doing is just blocking DC, isn't it? Coming off of the volume pot. If there was any DC on the volume pot, that's all it's going to do. And I think George is just saying there that he's done them before and not used bipolar caps. I don't expect it makes any difference. But if you say that, George, why would they have done that in the first place? Because Hacker are usually quite OTT in what they do. So why would they have gone to the bother of putting a bipolar cap in there, where they could have easily put like a 10 or an 8 microfarad normal cap in? Why would they put a bipolar cap in specifically? It's not a mistake. It's written in their schematics that it's bipolar. So they would have done it for a reason. Anyway, let's crack on, shall we? Let's crack on. I've got the desoldering tool ramped up. So we've got 200 microfarads. Let's get those out first, shall we? Got the lovely white hunts out. I don't think they've got date codes on them. Doesn't look like it. Just says WAI on it. So you can hear how silent my desoldering tool is these days. Amazing. Why didn't I do that years ago? I don't know. The white hunts. A rare beast. See if we can get them out in one piece. Pretty early circuit boards these as well. Is that one loose? Let's get that one loose as well. Where's that one going to? It was going from there to there, I think. I think you've done one of these, George, haven't you? Because you had the one with some idiot had put a lamp in the top of it. Remember that now. I was trying to rack my brains as to when you'd done one, but that was your upcycled radio, wasn't it? Very nicely done. Hi Brett, how you doing? Spanky's there. Better late than never. In time for the white hunts to come out. I think Spanky wanted these really. I think he actually wanted these. Okay, so it's marked on the board positive and negative. There's not a lot of indication on the actual capacitor at all as to which way around is which. Let's go to the overhead camera. So there's the cap I've just taken out there. 100 microfarads, 25 volts DC, PWV128 WAI by the looks of it. So the top of it is all white, and the only indication I can see of a positive is that some little red dot there. That must be the positive indicator. As I say, I've not seen one of those before, so Most unusual. So there we are. And I think this is the same value, so I can do both of these at the same time. So do we go radio or do we go, I think we're going to go axial if I've got any. So really I've got low stock on my axials now. I had a bit of a run on them. So yeah, that's exactly the same. Same markings, same little red dot underneath. Albino hunts and rare beasts. Rolf's in. Afternoon, Rolf. You'll have to play back to the beginning, Rolf, and ever listen to my my building dilemma, mate. You might know, you might have got some tips for me. You never know, because you're a bit of a handy DIYer, Rolf. How you keeping, Brett? So yeah, we've got 200 microfarads there, ready for cap bingo. We've only got 4 electrolytics in this, so it's going to be a quick session of the bingo. Let's get some. I've only got 2 cotton buds left. Look. Tell you, we've done a hell of a lot over the Christmas period. A lot of valve radios, and I've got a few in the wings waiting as well. I've got one actually that I will reveal today to you, and that's if you saw Chris's video this morning, he did a DAC 10. Well, I've got another DAC 10 here that's a bit poorly to do, so I'm sure that's the Bush DAC 10, which is a valve radio, very similar to the 98. I did have a DAC 10 here, or I have still got a DAC 10 here that's Sean from the Man Cave Workshop very kindly donated. In fact, I still think I got a couple things outstanding on that. I've got to put another silver mica cap in that I've bought but never got round to putting in. Right, let's just clean the board up in the area. I'm not going to put too much isopropyl on this side if I can help it, because it will get rid of the screen printing on these. Thomas Kitts, how you doing, mate? Hi, Thomas. Right. So let's do those first. Let's see what we've got in the way of axials. Yeah, we've got plenty of hundreds, so we'll pop a couple hundreds in there. No, they were 25 volts, and what are these? 25 volts, there we go. So keep them down, because I'm sure I'm going to need them again in a minute. So let's have a look. So if we do them that way around with a positive there, where will that look? Or do we want to do them with the negative and bend the positive? No, we need to do them that way. So I'm just talking to myself again as usual. So I could do these as radials, but the leg spacing is quite large on this, so they wouldn't look particularly nice. I don't know Jeff is having this radio. I hope he's having this radio. He's quite keen to have it as authentic looking as possible. So have another bite of my sandwich. There we go. Right, let's get a bit of soldering done. Let's pull that down on here, I think. Saves me stretching for it. Be interesting to see what these white hunts are like. I have to put some flux on the next one. I think that one didn't solder brilliantly. So I've got a few things still outstanding from the Christmas streams that I never got round to finishing. One was the first Murphy radio I did, where I created my own faults on it by very nicely pulling off the wires to the switch. Got that right, yeah, okay. So we've still got that one to put back together, and I've got to put all the valves that I pinched out of another radio back in, and I've managed to get another U404 valve as well. A U404 rectifier valve. I've managed to get a second-hand one, which was great because I didn't want to spend 20 quid for one valve when the whole radio only cost me a tenner to start with. So yeah, I didn't really want to spend that much. I'm sort of in for a penny, in for a pound now though, really, because of all the hunts that were in the blooming things. I can't believe how many hunts were in those radios. Unreal. Are white hunts politically correct? Very good, Brett. I fell into that one, didn't I? I'm easily led though, that's the problem. Tea please, Louise? Happy New Year to Thomas as well. Braid to take the solder off R600 faceplates, etc. Right. So yeah, we've got a DAC 10, a Bush DAC 10 coming up soon. We've got Commodore 64, which we never got round to. I'm also hoping to get that valve tester up and running. That's another must for this year. Well, let's get this one done across here. I'd still like to know why they would have used a bipolar transistor in that area, especially from George, if he knows why they've used a bipolar transistor on the base of the AF amplifier. So they would have done it for a reason. It wouldn't be just because that's what they had. So what's this one here? C1, that's marked. 100 microfarads at 12 volts. So. Dally. Goat, what's that? What's that, Benji? What's a goat moment? We can't have random goats. We need proof that the goat is legit. So I've only got 25 volt hundreds left. I've literally only got 2 left of that. So it's gonna have to be the same as the other ones. Get this one done. Also, never got a chance to play with any of the CB radios either over the Christmas period. It just seemed to go really quick, didn't it? I mean, there was a couple radios that came out more than once. Some came out multiple times. Okay, so we're going to get this bipolar one done. It is marked positive on the board, which is unusual. I really don't know why. Perhaps they were ahead of the time. Hunts is pronounced. Yeah, we've got that, George. Benji likes blue caps. So here's the controversial reversible transistor. Transistor? Where is it? Where's the goat? Oh, the goat worked and they decided to pack up. Just give up the goat. Maybe not. So yeah, this is the reversible one. Let's get that in. So it's definitely reversible. 8 microfarads. It's red on the top and red underneath, so it's non-polarized. But if you look at the board, it has got a positive screen printed on the board. So strange. Strange. Very strange. But anyway, I've got 8 microfarad bipolar, so that's what's going in. Because I bought them specifically for doing these radios with. And they're a very pretty colour too, look. Eight microfarad bipolar. And I got these from Cricklewood. So 8 Al cap, 8 microfarads, 50 VNP volts, non-polarized. So you see that both sides of the cap are crimped. I don't think these are particularly cheap from Cricklewood, but they do sell them on eBay as well, I believe, through their eBay shop. Whether it's any cheaper going direct to their website, I don't know, but there you go. That's a little plug for Cricklewood, because they do some stuff that's not available anywhere else. It's slightly pricey though, I would say. A bit overpriced, but you know, what can you do? If you've got to have it, you've got to have it, haven't you? If you've got to have it, you've got to have it. So we're going to put our bipolar cap in there. Very nice. I think, can't you fit two 4 microfarads back to back or something to make an 8 microfarad bipolar? I can't remember now. I have done it like that once before I got these. Nice. There we go. Recapped. No problem. No problemo. So, have you all got your bingo pens ready? Have you all got your bingo pens ready? First capacitor bingo of the year. Coming up. So, was it a total waste of time to replace those or not? That is the question. I got there. What's that, Benji? Oh, with the goat, you mean? Need lithium grease. Paddy, how you doing, mate? Series, you have the capacitance. That's, oh, you do, right. So you'd have to put, no, series, parallel. Yeah, parallel, I think is the way to go with it. I can't remember now, but I'm sure it was paralleled up. Two parallel 4s, was it? To make 8. Right. Let's go with the elusive white hunts. What do we think these are going to be then? 100 microfarads. Hunts number 1 then. 100 microfarads. If you want to go at the ESR, extra points for ESR recognition. But the rare white hunts. I'll have to put these in case Jeff wants to play about and stuff them himself, but I'm sure he won't want to touch it once it's been done. $100 microfarads in. Place your bets. 147, 167. Oh, there's no confidence in the hunts, look. There's no confidence in them. A vote of no confidence for the hunts. 140. Oh, so what you're saying is they are two polarized caps, so you have to do them in series. I see what you're saying, Timothy. Got you, mate. Yep. I can remember messing about with them, well, when I did them to get the value right. And it was a bit messing about orientation on them. From Spain? You're in Spain, Paddy? What's going on? Luigi reckons they're going to be bang on, look. He could be right. It could be spot on. Keeps having a stab at the ESR. Afternoon, Doug. Just in time, Doug. 100 microfarads. What do you think? Quick, I'm going to push a button. I'm going to push it. Happy New Year, Doug, by the way. Shall I have another bite of my roll a minute? Lovely weather in Tarajevo. Sounds nice, Paddy. Are we all done? I'm going to do it. It's not bad. 130. Pretty much 130. Timothy Cans 126. It's Timothy, I think. Let me just make sure there's no more up. 147. Timothy with 126. Winner, Timothy. Well done. Next one then. Exactly the same. Exactly the same. 100 microfarads. White hunts. 25 volts. So that one wasn't too bad. That wouldn't have caused any issues, would it really? That would have worked okay. I don't know how long it would have carried on working for, but it obviously was on the up. But 30 on us at 30%, 130. I'm not sure. You've been testing a few recently, Timothy, have you? Brett's going with 147. 125.5. Timothy's gone 130. It's gone on the nose. Is it going to be the same? Paul's gone 128. All around the 130s, aren't we? 121. Feel the power 180. Gotta be, Phil. 126, 130. We got a double 130. Doug's going 140. 14RO. There's the rain that was forecast, hammering down, very nice. Les Jervis, welcome Les. Good to see you in there, mate. 123.2. Yeah, never know. Very precise. Anthony, 111, 111.5. Last one was 130, but it doesn't mean to say the next one's going to be. I still can't get over how quiet that desoldering tool is. That was a pain in the neck for years, that was. All I had to do was change the fan. Unbelievable. Right, I'm going to push a button. We've slowed down, I think we're there. Is everybody in? Rain means we'll get it soon, Paul. Yeah, Paul, you're down. Is it Plymouth you're at, Paul? 127, Rob's in. Right at the last moment. Let's hit it then. Oh, 126.6, not far off of the other one. Who's closest to that? And Thomas is 126. 123. See, if you'd gone 126.2, Les, you'd have been there. I think Thomas is 126. It's got to be Thomas. That's pretty much bang on, Thomas. Hang on, no, Rob's closer. Rob's just fractionally closer with 127, isn't he? He's only 0.4 out. No, I got that wrong, haven't I? I've gone the wrong way. No, I'm right. Rob is closest. Oh, Somerset, of course. Bridgewater, yes, Paul. Rob, I think that's Rob Cross. Only 0.4 out. That's you, Rob. Unless anybody's seen any different. Well done, Rob Cross. So, what do we think about a Dally then? So both of those hunts weren't too bad. They could have potentially stayed in there. They've gone high, but not massively high. So this is again 100 microfarads at 12 volts, but this is now a Dally. So how's this going to fare against the hunts? Better or worse than a hunts? What do you think? It probably is coming up your way, Paul, because it normally comes over the moors from here and then heads up north. So yeah, you probably are going to get that in about an hour, Paul, I would say. $137 for Timothy. So again, this is 100 microfarads, but this is a 12 volter now. So you'd expect the ESR to be slightly higher with a lower voltage cap, but Phil's gone 180 again. It's 180 on everyone, Phil, isn't it? Even the H, you're going to go 180. I can sense it. Tell you what I have got to do, and I don't know if I did it or not, is change the batteries in my LCR meter. Pretty sure that had a low battery problem last time, or did I do it? I don't know. But we'll try and check that 0.003 in a minute. Or 0003. Keep it down here now. It's blowing a hoolie down here as well, so it's blowing its way up to you. What, on the Dally? Yeah, they're not very nice caps, Chris. Here we go then, let's push the button. Are we all done? Still got some stragglers. Spanky's gone 135. I think this one will be high, but I don't know. Let's have a look. Oh, ho, ho. In circuit leaky. 24.8 ohms. Shows how rubbish Dallies are. Look. Let's just give it a little bit of a wiggle around, because it might be the legs are a bit dodgy. No, it's definitely knackered, very knackered. So I can't remember what the original state of this radio was. I think we did get it working, didn't we, after I changed the oscillator transistor. But that Dally is absolutely knackered. Let's see if we can get a reading on the LCR meter with it. Let's try the LCR meter, see if that'll read it. So we're going to be in the nanofarads, I would think, on this one, because it says not readables. Let's try it with this one. Are we in capacitor? Yes, we are. What? Strange. This one's given it at 224 microfarads. Look. What's going on there? Has my battery gone in my Atlas LCR meter? Sorry, ESR meter. So this is saying 224 microfarads. Yes, I am going to, Brett. I think it's just quiescent on both of the output transistors on this one. Let me just check this again. Let me just go across that with the leads a minute. Still saying in-circuit leaky on the ESR meter. Is that because it's got such a high ESR that it can't measure it? I'm not sure. Oh, it's measuring it now. It might be dirty terminals on it. It's bizarre, isn't it? I think it's reforming as I'm testing it. It's creeping up. It's reading 129 now. I don't know if you can see that. But 19.9 ESR. I don't know. It's knackered. And this one has got low battery fault. Look, so I'm going to need to change a battery in that one in a second. I will get it done, because otherwise, every time we come to test something, I keep getting this low battery and I don't bother. So the one we've all been waiting for is our bipolar. It's absolutely knackered. So 8 microfarads, bipolar, reversible. Nobody knows why except the hacker engineers. So 8 microfarads, and it is an Elka mode as well, which is not a good thing. So it's a TCC Elka mode at 8 microfarads. Place your bets. I don't know who got that one really. It was roughly 130, but then on the other one it read 200 odd, so I think that was a failure. I think you put them in series to make a bipolar, but I've never tried it. Double 8. What's 16? Phil's gone for 16. Double 8. Les 8.5. Very specific, Les. My personal thoughts is this one is going to be knackered as well, because all the ones that I've had in the past have been knackered. Obviously a technical term. So it's 8 microfarads. What's the voltage on it? 12 volts DC. 50, Anthony. Could be. You could be right. Timothy did one recently as he needed a bipolar on feed to a speaker, 2 caps in series with negative joined. Your diodes across each one as well to ensure no reverse polarity. Let's come up to you now, Chris, has it? Let's do it. Not mental, to be fair. Just under 15 microfarads with 1.86 ESR. So it's fairly high ESR, but 14.95. Here we got Timothy's on 12, pretty close. 16.6 for Brett. $10 for Luigi, 13 for Benji. Benji's closest, I think. Oh, 16 for Rob. Oh, 13, so 1.95. I think it's Rob, isn't it, with 16? I think it's Rob again, isn't it? I think it's you, Rob. Mr. Rob Cross. Again. So yeah, knackered, but not mental. Well, saying that, it's nearly 100% out, and it's nearly doubled itself. Right, are my batteries handy? Let me just swap the batteries over on my Peak LCR 45. It's always worth getting an LCR meter. Most multimeters are measuring it these days, but it's quite handy. I think it's one of these batteries, but I can't remember. One of these has got a weird battery in it. No, it's one of these 23A 12 volt batteries. It's one of these little diddy 12 volts that go in these things. So if no one's seen one of these having its battery done before, you're going to know. Because you do get through a few of these. I put quite a few batteries in these over the years. Get off. There's our battery. In with a new one. Just be careful that you don't dislodge the buttons out the front, because they're just held in by gravity, really. That together. Get off. Just turn them backwards till they click, so you're not putting a new thread on it. And the last one. Don't have to hammer them out, they're not going to go anywhere. There we go. Back as we are. Sorted. A sling that one away. Right, let's whip this one out and have a look. I'm just going to lift one leg on it, I'm not going to take it right out. So this is our 0.003. So we're going to want the LCR meter for that one. Because although my multimeter will measure capacitance, it ain't great at doing it, to be fair. It ain't great. So as we put a new battery in, I think what we'll do is we'll just calibrate the leads on this one. So to calibrate the leads, you just need to keep pushing the menu button till you get to probe compensation. Hit enter. Short the probes and press enter, it says. So short the probes together. Press enter. Now it does a countdown. Probably slightly different range, Anthony, I expect, that's all. It might be different measuring frequencies available because I can select different frequencies. So then open the probes, push enter again. So yeah, if you use different probes or put something in between. Thank you, Rob. There we go. So let's try this one. So let's go across there. Let's just prop that up. Let's use one of Sean's lovely proper things for that. So it's that way better. You can see that. There we go. So let's connect to the other side, which is there. Will it stay on there? There we go. Ooh. So basically it's 4.3 NF. 4.3 NF. So where's my bit of where's my ready reckoner? So where are we? 4.3 NF is going to be, this is 0.0043, so it's not a massive way out, is it really? So it's 0.0043 and it should be 0.003. If I was going to put a new one in, it would be 0.0047 because I don't think I've got any 0.0033s. Have I got any 0.033s? No. No. So yeah, it is a little bit out, but not a massive amount out. Not enough to worry about. It's 4.3 instead of 3, so it's 1.3 NF high. I'll just quickly check to see that I've not got any here. Any 3.3 NFs, 4.7s. No 3.3s. Are they available as ceramic discs? Ow. No, I've got 2.2. I've got 4.7, but I haven't got any 3.3 NFs. So that one's going to stay. I don't think that's going to be too much of a problem. So let's solder that one back in. Staying for now. Right. Let's get a bit of reassemblage going and we'll have a look at setting up the quiescent current. And I don't know if it is a midpoint voltage on this one. I think it's just current, but we'll see. Boy, Benji stuff. So Timothy saying you think you're right about C4 negative feedback, so it'll pass the higher frequencies, will reduce gain and stop the amp oscillating at above audio. Right, so it's like some high frequency sort of cut-off then, perhaps. So you're after a 3-element 10-meter beam. Hell, that's a big beastie. I haven't got one, Paul. I haven't got one, but nice bit of kit if you can get it. That's me. A bit close there, Graham. Because I'm standing on the lead. Try that. Thanks for that, Timothy. Right, setup instructions for this amp then. Measurement of quiescent currents in T6 and T7. Let's get that up on the screen for you. So this is what we're going to be doing next. If I can find it. It's on here. You just sort of screen out first, Graham. Short battery life, maladjustment of RP2 and RP3. So yeah, maladjustment of these will cause severe distortion and may also result in short battery life. So, gotta be done. Right. Off alignment, there's a wobulator. We're not going to be. I don't think we're going to be wobulating. Okay, so here we are. Let's get that down a bit further. So we're looking at this measurement of quiescent currents in T6 and T7. So that's what we're going to do next. Make sure you can see that. Yes, you can. So remove the links. So we want to remove both links, shouldn't you? shunt the amplifier input with a shorting link. In other words, we're going to ground the input out. So it looks like we've got to have 2 meters, one in each circuit. And both of them need to read 3 milliamps. Right, let me have a think about this and how we're going to do this best. So as you can see it, I ought to get myself one of those multimeters really that you can actually put onto your desktop, so I can share it directly with you. Right, volts, amps, 200. 200 milliamps maximum, and that once I go to that. Okay. So that's the plan. So basically we've got to shunt the amplifier input to ground, and then take the links out, and then adjust them both until they're 3 milliamps. But you must have to do them both at the same time, otherwise you could put too much through one of the transistors, surely. Okay, alrighty. Now let's see which is the input. So again, this isn't labeled, so I'm pretty sure that the input is on the base of this transistor, what do I keep saying, transistor? On the base of this capacitor, isn't it? So this has got to be the input, because it goes through that capacitor, through that resistor, and then out to the first transistor there. So it's got to be on the bottom of this one. So I've just got to shunt this to ground, so I've got to put a link between here and there, perhaps. Either way will work, or here and there. Let's find out a little bit of linky wire. Stinky linky. Use that bit of black wire there. A bit thicker. I just pop a little bit of flux on the board, and where was it again? Where are we? We're here. So it's between there and go to there. Didn't want to take solder that one, not at all. There we go. So that's now shorted to ground. So I'm not going to break the seals on these at the moment until we absolutely know that we have to break them, if you know what I mean. Power supply wise, we've got to have both of these connected up individually with 9 volts. Let's get myself sorted. But first of all, we need to get another beer in, and Chris, I've still got some left. All the gear, no idea. Christmas present. Thank you very much, Chris. Still got some left, look. Amazing. So we're going to have to pop this one down the neck a minute, because you know it is Sunday, and I haven't got any new beers in because I've done the advent calendar. I've been surviving on Tony's and Chris's generous beer donations. Oh, I pulled that in a bit quick. No, it's good. It's good. So cheers everybody. Happy New Year. Still I'm eating all my lunch yet, but I'll get there. I'll get there. Right, let's get the chassis back up. So only really want this for its speakers, don't we? Just zoom out a little bit for a minute while we connect it all up. We don't need we haven't got a ferrite connected at the moment because I cut that off, didn't I? But we shouldn't need that. No, we're not going to need that for the amplifier setup, are we? We don't need that connected. All we want is the amplifier plug in. Okay. Right, now to sort out the power. I must make some more leads up. It's got to be on my to-do list for this this year. So we've got 9 volts set there. Only got one set of leads though. So we need another set of leads. Got a BNC, but that ain't no good. Will these fit in there? Don't think they will, no. Yeah, a bit slacking on the leads situation. I'm going to have to go and get me other 9 volt battery, aren't I? In fact, I could put a PP9 across the terminals, can't I? That one out. Gone, lost one of my leads. This is 1/2 of our 9 volt. I've got to take the... Should have done that first, shouldn't I, really? Got to take these leads out. I think I've already set this one up once before, but I'm not 100% sure, so I'm just going to heat them up and pull them out. That one. Let's move that one out of the way. Do the same for this one. It's going to be easy to pull from this side, I think. Yeah, I don't think we have done this one before. We certainly have done one before, but not this particular one, I don't think. We've done a couple of the quiescent currents on these. There we are. So that's our 2 little leads that we need to clamp onto. So that's that one. All gets a bit busy on the bench when you're doing these because you need 2 meters and loads of leads. So let's just clamp another battery onto there. Let's grab a PP. What have I got here? I've got a PP9 somewhere. It's a lithium ion. Better not stick too much up it. Let's stick that one on. See what voltage that's got in it. Yeah, 9.6, that'll do. I'll do nicely. So you can connect one on, the other one's going to have a lead across it. That's that one. Getting there. Right, let's just check the chat a minute. I'm not still on that page there, am I? No, I am back with you. Okay, good. I thought for a horrible second I still had you on this screen. Tassimo. Afternoon, Gavin. Happy New Year to you as well, mate. Thanks for popping in. Right. We're talking about coffee, I think. I'm getting confused now. Right, next is going to be hooking the meters up. So they both need to go in to milliamps. I'm not sure if I killed this meter previously because I keep forgetting that I've got it in milliamps. So here's 1 meter. Let's sort some probes out. Here's the other meter. I'm using my Precision Gold Maplin's meter. So let's go with the clip on one side. I always get these the wrong way around no matter which way I do them, so I usually got to end up swapping them back around. And we want just a different probe end for that one. Let's get me multimeter ends out. I've got to watch Chris's video on the test leads he bought because I'm desperately in need of some more test leads. So I think Chris's video will come in very handy for that. Oh, they won't fit on there, will they? Right, Mrs. Cruncher's just off out with the doggies. Well, not out with the doggies. She's off to the shops. Right, that's 1 meter connected up. Let's see if we can hook this other one up. Oh. This one's a bit tricky because there's not a lot on the ends of the leads on this one. Let's flick it on. It's not a great resolution, this meter either. It's not brilliant, but it'll do. It'll do. Right, so let's turn it on and see where we are then. I think that's everything connected, isn't it? I'm grounded out there. Let's pop that one on as well. Let's go to on. So we're not reading anything on this meter for some reason. Shouldn't be AC shit, no. Why are we not reading anything on this meter then? And we've got 5 on this meter, so let's just pop that off a minute. So let me check my connections on these probes. Try that again. Nothing on this meter. Have I previously killed this meter, I wonder? Let's get another one. What else have we got in here? Into the land of meters. Somewhere in here I've got a fluke buried. There we are. Okay, will these probes fit into the fluke? I might have popped the milliamp battery in that one. You never know. Oh god, they don't fit in there very well. They do go in there. Rubbish leads. Let's try that again, see if that one reads. No. So either we've got no reading there, I'm not confident that those probes are in there properly. I think they are. Let's try that again then. Amps AC. Must be DC amps, doesn't it? It can't be that far out, can it? Obviously I've got the leads the wrong way around. Let's just swap the leads around a minute. Try that again. So this one's too high. If I wiggle it, let it. These are rubbish, these blimmin' things. So that one's about 5, and this one, wiggle it. So that one might even be open already. We're running on just one output transistor maybe. That one's too high and this one's way too low, so I think we have issues. Afternoon, Milling Chip, how are you? So time to investigate that that side. Let's make sure I got that on properly. Make sure my leads are correct, which they do seem to be. Yeah, so we've got problems on this side. That's too high. I mean, that I can pull that back a bit. Which way it's got to go. Let's put that one down, move that battery out of the way, and just pull this across a little bit. Oh Christ, wrong way, wrong way. Get back. That's better. Let's keep that down on 3. No movement on the other one, despite if I pull it about, I can slide this one already, so maybe someone's been in here and so get it as a 0.2 milliamps, so we got no good. It's no good. We just pull that about a bit. So could have a break on this one. Could be dirty, so we'll give it a squirt first. We can find it. I can find it, but I've got no straw in the bottom of it. Yeah, you can. Daz, how you doing, mate? Good to hear from you. Oof. Happy New Year, Milling Chip. What am I up to here? Have I missed anything? NJT, how are you, mate? You got one of these meters too? No sound? Oh no, I muted it because I was talking to Mrs. Cruncher. Can't quite see the board. No, I know you can't. It's in. We're in deep. We're in deep, Brett. I can show you the board a bit better if you want. Let's have a look. Where are we? So this is the one that we're messing with at the moment. So this is the one that's giving us the dodgy reading. Let's just darken that down a fraction. It's a bit bright. So I'm just going to hit it with a bit of service oil because it might have a dodgy, whatchamacallit, a dodgy slider. I can move this one with my fingers really, so I'll just give it a bit of a go up and down. It's not going to go now, is it? Just try that. .7. .5. Yeah, there's definitely something wrong with this side of it. Got no reading on this side at all. Nothing shorted out. Okay, let's pop the power off. I'm gonna need to take that apart and have a look. It's not playing games. So yeah, you basically adjust it by just moving this slider up and down this track. But the problem you get with these is they corrode, and as soon as you try and move them, it actually breaks the wire, and then you're stuffed really. The only way you can fix it is to rob another one. So I'm going to take the board out and take the board out. I mean, it could be a problem with one of those seleniums, I suppose. Not seleniums, one of those metal rectifiers. That's what I'm trying to say. Right, let's get all this stuff out of the way. Let's get back in there. I've got leads and that everywhere here. Right, back out of the board, back in the room. So we're on the RV2. And what transistor is this one? I'm not sure, but the one that is fed from RV2. So let's have a quick look at the schematic. How you keeping, Daz, anyway? Not heard from you for a while, mate. Hope all is well in Dazland. No, it's not that one. It's on there, Graham. Reading should be adjusted by means until they are 3 milliamps. Yeah, should be 3 milliamps. Got to be a problem with one of those. And I'm just going to get to the schematic a minute, and we'll just have a look and see which one we're dealing with. And it is this top one here. Right, it's not a very good scan, this one, but it's good enough. So yeah, the MR1 is across that, so we could have a problem with MR1 in theory. So let's just get rid of me. So this is RV2. This is the link that we got broken. We got a meter in this link here. So this is T3, one of the output transistors. This one, T4 and RV3 is fine. We've managed to get that one adjusted down here. So I'm just looking to see what else we've got in that circuit. So we're going across there. So we're measuring from ground. Where are we measuring? So we're measuring from ground. Back through that way to the wiper. So if we measure RV2 to start with, we should, is that connected to anything? It might give us some weird readings because we've got this MR1 across it. We're also in parallel with another resistor there, so might need to pull that one out to test it. So it could be a problem with MR1, could be a problem with the transistor, it could be a problem with R8, it could be lots of things. It could be a problem with the output transformer, that winding could be gone. It could be lots of things. It could be lots of things. Am I calling you Graham? Just said radio off syndrome for a bit. I could get the feeling. Get the feeling it does. Anyway, let's have a look. RV2. I think if we just measure across it, we're going to get a weird reading because this rectifier here is across it as well. This one, yeah, it is across it, and that's our other resistor, R8. We'll test it in circuit, see what it's like to start with. You might read it, you never know. I'm not confident though. I think we're going to have to pull it to get a decent reading on it. So it should be 150 ohms. Obviously the wiper adjusts between that. So let's see if it'll measure in circuit. And it's measuring. Let's make that sure. Oh, hang on. Oh, this is the joy of this meter. Is you've got to swap back to the other probes. Right, let's just make sure we're okay there. Right, I've got to swap the probes leads out for. So it's reading 143 ohms. It's obviously reading the rectifier resistance as well, which is there to there. Yeah, so it's reading the rectifier as well. So let's just pop one side of it up if I can. I won't disturb it too much because these are horrible things. The less you touch them, the better, really. Right, that's out of circuit now. Let's try that again. Make sure we are totally out of circuit. Yes, we are. Let's double check that. Okay. If I can hold it still. 147k. Okay. So let's now go from one side to the wiper. 66 ohms. And the other side. 81 ohms, so that looks all okay. So why can't we get a reading? Anybody got a clue? Brian Logan, how are you, mate? Your fluke will only read down to 10 milliamps. Okay. Put the multimeter across C5 to see it's holding its charge. C5, C3, C4. C5's brand new. I mean, there's not going to be an issue with that unless I've got a dry joint or cracked joint. No, nothing there. C5 looks good. I suppose we can check. Can we check these rectifiers on diode mode? Nothing that way. Yeah, and this one. Now we got a different drop there, but that's 0.36, and that's 0.14. What's in there? What's that pin? So I'm just checking continuity quickly between these points. That just goes down to there. Let's just check that we've got continuity there. Here we have. So the only other thing in circuit is this other resistor here. So let's just see if that'll measure in circuit. No, okay. That's because I wasn't measuring the right terminals. Let's try that there. 1.6K. R8. What should R8 be? What should R8 be? I will swap back to the analog meter in a minute. We might be barking up the wrong tree, but let's just have a quick look. No, I keep clicking on the wrong one. It's on there. R8 should be 2.2K. And what did I say I'm getting? That's quite a way out. Let's just pop one leg of that out as well. In fact, let's pop it completely out, because it's one of these ones with the end caps on it, and they don't like being... They don't like being messed about with, otherwise the end caps come off. So let's take that out of circuit. $2.2K. Let's try it out of circuit. It was possibly in parallel with something else. What's in parallel with that? So stay still. Yeah, he's definitely way down that one. 1.6K. Let's just check the color code on it. Make sure that we haven't got one that's supposed to be different for a reason, because it's a different version or a different spec on the board. So I've got brown, green, red, and I'm sure you've all got it by now. This is old school caps. This is brown, green. Yeah, so that's right, 1.6K, but in the manual it says it should be 2.2K. There, look, R8, 2.2K. What's going on with that? And R9 over the other side should be 2.2K. Well, looking at this, they are... Where's R9? Yeah, R9's 1.5 as well. What can you do? What can you do? So it says it's 2.2K on the schematic, but actually on the board they're both 1.5K. Silver band, so the tolerance on that is 10%. So what's 1500 plus 10%? I mean, that's going to be okay, isn't it? Yeah, a bit strange that. So it could just be that I need a third meter. If the fluke will only test down to 10 milliamps. Yeah, it doesn't actually tell you on the front. Does it tell you on the back what its range is? No, it doesn't. So we'll stick yet another meter in. We'll put it all back together and have another go with a different meter. If I can find my stuff that I chucked on the floor everywhere. Rectifier no good. Thanks to the heads up there. I don't know that it's a selenium, it's a metal rectifier. I think whether that is selenium, I don't know, but the only way to test them really would be to pull them out of circuit and then put the meter across them. But what do you put back in their place if you pull them out? Do you just hook another diode underneath the thing? Perhaps a later mod. Yeah, almost certainly, Paul. It might be an earlier. This might be. I don't know if this is an earlier or a later board. It doesn't really say. So I think the later version uses a totally different board altogether. Let's pop that one back in because that's obviously not far out. I'm sure that's within spec. Right, quick comfort break time. I will be when I eventually get there. I can eat my sandwich on the way as well. Right, I'll be back in a sec. 2 minutes. Right, the dogs are going mad because Mrs. Cruncher's back. Right. Just thinking if there's anything else we ought to be testing on here. Anything else we ought to be testing before we dig another meter out? Right, there's this one in amps. DC amps, 300 milliamps. One milliamp. Microamps. Alright, we could try the FET meter. Right, what are we saying then? Let me just check out the chat. Selenium is a little higher, maybe 1 volt. Happy New Year, Jay. One volt. So we had one that was. It might be worth pulling them a minute then, or comparing them. Shall I get another board? Compare them with another board a minute. Let's do that, because these old things don't like being pulled apart much. Now I've got another one somewhere. I'm just going to peel my Matado, my orange even, ready for the eating of, and I'll go in the other room and see if I can find one of my other RP17s. Right, what have we got? Is that an RP17 now or 17A? That's an RP17. That's where my other batteries have got to. Obviously this is one that we've worked on before. So we've got my grey and beige, grey and white one. It's obviously in parts because the top's all fallen off of it. But it looks like this one's been sorted. Looks like we've done a bit of a zapparoonie and it is working. We've got some interesting batteries in there. What have we got in there then? Obviously one of my, that's where my other 3D printed one is. Okay. So let me just pop this one out and we'll test the rectifiers on this one. So I suppose it could just be running on one output transistor as well, which could cause an issue for sure. Let's get that out of the way before that shorts on something. Certainly got these on nice and tight. Cool. Ah. Cool. Wasn't hellish tight, that one. And that one. Right, are these going to come out? Problem is the vinyl catches on the edge of the batteries on these. GP. Original PP7. And then we've got a 3D printed one coming on out. Radiocruncher special. And here we have another amp board. It's been recapped. Looks like I might have moved it. Yeah, it looks like we've done the quiescent current on that on this one. So let's check the rectifiers on this one then with it in circuit. See if these measure roughly the same. Where are we? Here we go. So I need to put the resistor back in place to get an accurate reading, but let's do the first one. So this one measured, I can't remember what it measured last time with the other board. 100, hang on, I need it diode mode, don't I? .15, and the other one 0.14. Okay, okay. Let me just solder that one in then. I'm just going to solder the resistor back in because I did take the reading with the resistor out of circuit. The bar resistor, that is. Right, so let's do the old one. Yeah, that's more like it. So now that they're reading fine now. Now that resistor's back in circuit, they're reading exactly the same. Okay. So let's have a look, see what that's reading across that way. 144 ohms, and this one 153. Okay, we've got exactly the same resistors in here. The 1.6k or 1.5k's. That one's reading 1.3 odd, so that one's a little bit low, but yeah. So it looks like your rectifiers are okay, and that's proven with that other board, and I'm sure that we've done an alignment on that one on a previous video many moons ago. Could be years ago. Could be years ago. Right. Let's catch up with the chat. Okay, I think hopefully that's That's answered our query on that, hasn't it? Are we happy that that's good now? So it could just be down to my meters. So let's hook it up again. Chisel. Let's hook her up again. So if the rectifiers are okay, everything else is okay, it could be potentially that that transistor, couldn't it? Well, it could be one side of the winding, I don't know. Boom. Right. Let's quickly check this transistor on diode mode. I don't know whether it's NPN or PNP, but see if I can get a. So if I put the positive on the base, nothing. Okay, negative on the base. Yeah. I think that's okay. We got a different reading that way, or am I measuring the wrong thing here? 1, 2, 3. But then I don't know what's connected to that junction. Yeah, they're not open anyway, for sure. Let's carry on with what I was doing then. Hook it back up. Try a different meter. Gonna have to move that capacitor there as well because it's touching against the plug, which I don't particularly like. So we're gonna have to move that one around. Right, let's hook the speaker in. Too much stuff all over the bench again, Graham. Right, let's get this meter in then. Let's get an analog meter up because you want to see a bit of an analog action. Let's get this, as recommended by Chris. So we use, we'll swap them over. We'll mix and match them up a bit here. So this is reading the one that's correct at the moment. Hopefully I've got it on the right scale. I don't know if that's 1 milliamp, 30 milliamps, 300 milliamps. If so, it's probably going to be the 30 milliamps because we're going to be expecting about 3. So it's going to be I'm going to read this then. So if it's on the 30, that'll be 30 milliamps. That'll be 5 milliamps when it's just not going to read much. 1 milliamp, it would be full scale, wouldn't it? Off the end. That's that one. It's that probe and that probe there. So that's that one connected. Potentially. Let's connect this one up as we were. Probably the wrong way round, because it always the wrong way round. Set that through that. Set that one to there. Right, I think that's my 2 meters sorted anyway. You can't see the board for a minute. I'll sort power out now. What sort of powers? No, we'll do it the same as we did before. We're getting there. Bear with it. Right, let's hook up our PP9 again to the other battery terminal. What's the negative? Which goes to that one. Right, I think we're connected, so power on. Nope, because we're now in the wrong terminal, so I've just shoved that up the diode mode. That's not going to help the meter. Try again. I'll get there in a minute. Okay. No, we're not reading anything at all on anything. Why is this? That's definitely connected to negative, that's positive. Now we have nothing. What's going on here? Is Sod's Law finally caught up with us? Or am I connected to the wrong leads, wrong terminals? This one's reading nothing. Not even on microamps. Okay. I've never used this one before on that. Hang on, we've got a lead off. Let's try that again. Let's try that again. Okay. Well, we're reading about right here. You can't quite see the scale, but we're reading about right. That's on the 30 milliamp scale, and we're reading about just under 4 milliamps on this one. On the other one, nothing. So let's swap the meters over again a minute. We'll just see how is it best to do this. So okay. That's that one hooked up, and this one. There's the other lead. So I need another clip lead. Let's get a decent one. Okay, so this is the meter that we're interested in mainly. This one should now be reading our sort of 3.5, 4 milliamps. And this one is now analog on the dodgy side that we're not getting any readings for. Which we're definitely on. Right, let's try again. Okay, so we're now reading on a 4, but we've got nothing there. Let's go to 1 microamps. Next to nothing. It's not even reading 1. Why isn't it? Why are we not getting anything on this side? When I'm on the 1 microamp scale now, so we should be reading something on there, but absolutely nothing. 100 microamps, not milliamps, microamps, it's just reading. So we've got issues there, haven't we? I've tried it with 2 different meters now. This one's reading about right, 4, it should be about 3, so it's a little bit high, but easily pop that one back a little bit using the slider on that side. So we're around about 3 there. But this one and that side of the circuit is absolutely knackered. So there's something wrong there. Let's investigate further. Theo, how you doing, mate? Well, so I've tested the rectifiers against a known working set, and it's measuring the same, so I don't think there's any issues with those. Let's pop that back into normal mode for a minute. Let's unhook it all. So we've got everything everywhere here at the moment. I mean, what else would be throwing that out? Have we got an open resistor somewhere? Answers on a postcard, please. I've tested 2 different meters now, Tim. I've just swapped the 2 meters around, and they're both okay. Dead transistor, yeah, that's all I'm thinking it could be, really, Nick, but I'm not sure. That's what I'm pulling out next, anyway. It's got a different reading in circuit to the other one, so it could be a problem. It's certainly not showing as shorted, and it's got these whacking great ferrules on it as well, which doesn't help. So can I get in there with anything? No. So I'm going to have to use pliers on that. Ah, sorry for that, Theo. Unfortunately, you didn't win anything, Theo. I don't think you did anyway. I'm pretty sure you didn't. But it's the taking part that counts. And we did have a bit of fun playing a lot of old 78s and that, which YouTube duly hammered me for. But that was to be expected. So let's pop this output transistor out and have a look at it out of circuit. It's a bit warm, a bit warm. So we've got these big ferrule things again, which are a bit of a nightmare to desolder from, but persevere. I'm sure it'll be fine. It'll all come out in the wash. Right, what's it hanging on by? It's hanging on by the very first one. Right. That's the output transistor out. It was nice to see some of the regulars picking up prizes. It certainly was. And, it's good to give things back to those that spend the time to watch the channel, isn't it? Right, let's have a look, see then. Have we got a dodgy transistor? Bearing in mind the radio was playing. Good. So it's not the transistor. HFE's 92, which I think is probably about right for one of those. They're not great gain, I don't think. We'll just check it against the data sheet. Rob, nothing wrong. I don't know why you keep asking. It does bug me sometimes. You've done nothing wrong. You keep asking. Oh, you did not enter for the giveaways other than the radio. Michael, how you doing, mate? I don't know if I said hello to you earlier, Michael. So I'm just going to quickly check the data sheet for that. I could get the towers book, but it means climbing over a load of stuff, so we'll just use our friend Google. And what were these OC81s? I can't remember now. I'm going to have to find the data sheet. I should have to find the thing. I think it's OC81s they are. I think that's probably about right for an OC81, but never would check it just in case. Crooked Wood are selling them for £10.80 each, look. So if you're short of one, £10.80. Or a job lot of 4 for 45 quid. Dear oh dear, they're ridiculous money, aren't they? So let's have a look at all transistors. They're usually pretty good. No, we don't want to use your cookies. HFV. Oh, it says minimum 50. What did I say we had? I can't remember what we had now. I think we did have that, didn't we? Yeah, 87. So yeah, that one is okay. That one is okay. Brew time. And Mr. Spanky one as well. Yeah, Harvey's been trying and trying for a long time, hasn't he, to win something. Okay, so next I suppose we need to check the winding on this output transformer, because that's in the circuit as well. So God knows what that's likely to be, but it's going to be in the low ohms, I'd have thought. Let's check that. You won the record. Yeah. I was meant to ask you, Timothy, do you want me to clean that before I send it, or just send it as is? I've got one of those, I don't know, you might have a fancy record cleaner, Tim. I've got one that Gary let me have, a disco thing where basically you put cleaning fluid and you just rotate it by hand. So you'll have to let me know. Right, so let's have a look at this. We're expecting to see resistance here and not a short circuit and not an open circuit. I would think it'd be fairly high. 33 ohms, I think that's probably about right. Let's just check the other one. Let's say an open circuit. Yeah, so it looks like our transformer's okay. Let's just check it against the bottom of the board. Yeah, okay, so the output's okay on that. Input's combined anyway. We are running out of stuff to check here. We are running out of stuff to check. Our resistor is measuring okay. You know, we've got resistance between both ends. Resistance there. It's rambling all over the shop a little bit. 80 that side. 68 that side. So this appears to be making contact with the track okay. Our resistor's reading okay, that's not open circuit. No, the selenium's checking out okay. But I've just found the culprit. I've just found it. I've just found it. Sneaky, sneaky. We're going in. Spot the problem. Anybody see any issues there at all? Perhaps if I go in a bit closer. Anybody see any problems there? It's a bit grainy at that resolution. Just come back out a little bit. A bit over enthusiastic there. No worries, Tim. Have you got a record cleaner though? Because it does need a clean. It's only in one place, mind you, but it does play fine. We played it through. Can you see the potential problem? Les has got it. Spanky's got it. No worries, Timothy. Yeah. Sure enough, we have got a broken resistor. What a little sod that is. We're running out of stuff to check there. But sure enough, yeah, this R10, look, if I move it. Look at that. Broken right on the orange bit as well. So let me have a look where R10 is on the circuit and find out why that was causing the problem. I take it you've seen it now, Brat. It's R10 is open. It's very much open. So what does R10 do in the amplifier? Does it specify any use for R10? No. Let's see where R10 is in the circuit. Perhaps one of you can tell me why this would be causing it to... well, yeah, I can see why it would cause it to fail. Oh dear, I can certainly see why one side was okay and not the other. So let's zoom across to the schematic. Here's R10. It says 3.3 ohms, but it's basically between the emitter of T3 and the collector of T4, and we've got a center tap in between these two as well. So that open is basically cutting that one off, but this one's still able to go through this way potentially. Is that right? But yeah, it ain't going to work with a break there, is it? It's still working on this side though, which seems a bit strange because maybe it's the way the transistor is. Yeah, answers on a postcard, but yeah, that's definitely going to kill it. But I'm surprised it was still working at all, really. So that says it's 3.3 ohms. What is that in real life? Cruncher's usual faults: fairy transistors, broken wires, or cracked resistors. There would be no transistor conduction on. Obviously, one was conducting still, Simon, wasn't there? But not the other one. So it looks like we've got a. Yeah, it's definitely that, because that's on that side. R10, R11 is the comparative resistor on the other side. Let me just get that schematic up again. Yeah, okay. What I didn't show you was down here. So this is R10. This is part of this transistor circuit. R11 is part of this transistor circuit. So this one was still conducting fine, but with this break, it couldn't get down through this way. So that's going to effectively kill this transistor here dead, but this one will still be going because it's got its 3.3 ohm resistor there. So let's have a look, make sure that is actually a 3.3 ohm resistor and it's not one of these ones that could be. It's orange and orange, which I'm sure is 3. 3. And it's just gold, the end one. That's just a colour in it. So gold is 5%. So do they need to be matched? They probably do. They probably do need to be matched. So we might change those as a pair. If I've got some 3.3s, I probably have, because I have done these before. But that was well found though, wasn't it? Thank you, Rob. Okay, 2K4, 3.9, 3.3, there we go. Gold band as well. 3.3 ohm. I'm going to change both of those as a pair. Then they're matched. So that's my new 3.3s. These are half watt by the looks of it. These are probably half watt. They're bigger than the smaller ones. Does it tell me what wattage they are? It might do. It might tell me. R10 and R11. Tolerance 5 within 0.5. Doesn't give me the rating, but I would assume that because they're bigger than the others, that they're half watt and the others are quarter watt. Yeah, that's what I'm going to assume. Sure, half watt will be fine. So yeah, we've got R8 and R10, and then there's a matched pair of resistors over there, like R11 and R9. So I'm going to change R11 and R10, and I'm just going to use these modern, if I can get them underneath the camera, a couple of these, look. Half watt. I assume the difference in size, the smaller ones are quarter watt back here, and they're half watt. A bit different to today's quarter and half watt sizes, but right, let's take them out. Then hopefully we'll get some quiescent current action going at long last. It's good to have these, folks, though, isn't it? Rather than it just recap it and hope for the best. Just unblock my desolder gun. So that one. And R11. Right, let's get them out. Yes, we've still got mince pies, Benji, if you're talking to me. Still got one box left. Let's see what these measure then. So let's first of all test the one I've just taken out that's still in one piece. Measuring 3.33, look pretty good. What are these measuring? 3.5. That's not good, is it? 3.5, and this one is 3.49, so they're pretty much identical. In. My soldering iron's given up now. It's decided to turn itself off. It said I've had enough. You've had me on and not used me for so long, I'm giving up. Let's pop a bit of flux on that because it's pretty rank. Oh, I kicked that on the floor as well. No, here we are. Still no reply back from Pace about their lovely iron that they've sold me that I can't get spares for. It's still a current stock item. There it is. That's the culprit. Just broken completely in half. Carbon composite. You can see the carbon inside there, look. Kaput. It's good when a plan comes together, isn't it? Right, let's get our transistor back in. And then we can hook it up all over again. So we had lots of things to blame on that. We blamed the wire wound resistor, we blamed the meter, we blamed the rectifier, we blamed the transistor. But after all that, it was a good old resistor problem. Popping them down a bit further in the ferrule. pop our heat sink back on. Oh, I've done my fingernail up in it then. It's got an extra insulator in there now. Let's pop it. There we go. Right, we're back in business. Although that one's a little bit high up, let's just pop that down. Bit flusher to the board. Okay. Right, let's hook her up again. Yet again. Let's clear some stuff off. Really, once this is done, apart from a line in the radio, that is going to be it on this one, I think. I think it's had enough airtime now, this radio. The next time you see it, it will be hopefully nice and shiny and ready to go off to Jeff if he wants it. I'm sure he wants it because it's going to be famous now. Wenlock, good morning to you, mate. Happy New Year to you, Wenlock. Right, I'm just having a bit of a clear up here so as I can see what I'm doing. Test lead city here. Bits of metal hanging around on the bench which we don't want. Let's plug the socket in. Oh, I've got to change that capacitor around as well. I do not like that. Yeah, we'll get that done in a minute. Because that capacitor is touching that can there. Or the outer edge of that plug. So I'm going to get that swapped around. Right, we've got our plug here. Right, that's our power sorted. Let's pull that one off for a second while we get everything else hooked up. And I'm going to go back with the original digital meter, I think, because I don't know, I prefer the digital ones for setting these up. So yellow, so we've got a rubbishy lead. So we got a decent lead. Yeah, that's a white one, didn't it? Right, okay. Ben, how you doing, mate? Uncrunching. I've not fixed it yet. You need to follow along, Dom. You need to follow along. Right, so red and green to 1. We'll use this one as red and green. No, we won't. We'll use, where's my bluey? We'll use this one as the red and green, if I can find its probes. We doubted this one, didn't we? But it wasn't a fault of the meter. It was actually not reading anything because it was open. Right. So we're going white and green with this one. Where's the other lead? Down there. Right, that one's on. Here goes then. Here goes nothing. Let's pop the lead on there. Power. Oh, now we're getting there. So obviously this one's too big now because we've messed with it. 2.6. Let's move it, wiggle it a little bit more. 3.2. Fraction more. This one back a little bit. Obviously we've got the leads wrong way around on that one. No surprise there. So let's shove that one along a little bit. .2. They're horrible to set these. 3.1. 3.06. That's fine. That's good enough. How about this one here? We're going to get any more out of this one? Is it going to be? Is it going to be a pain? It literally is a tiny little movement. Oh, don't breathe. Don't breathe. I think that's good enough. We'll leave it there for a minute to stabilise up while I get the dribble of beer out of my glass. The nail varnish came crashing down just now because it knows that we need it, so we're going to have to put some nail varnish on it just to seal it. Let's give that one another wiggle. Shush. Who put that nail varnish in the way? So they are slightly interactive, aren't they? Because that one's gone down a fraction now, but 2.99 is good enough. I think we're going to stay with that. Don't you? So I'm gonna get all these leads and everything taken off. Take the power off. Right, so I want to seal these. I don't want really to do what they've done and stick a loop load all over the actual wire trace. It's better to do them on the back of the board where they're well, it's just paxilling board, it's not actually the wire wound bit, if you know what I mean. So what I'm going to do is just put a bit of nail, a little blob of nail varnish on the back, just to keep it there. A big blob of nail varnish actually. Oh, okay. Same on this one. And that'll stop them moving about. So just a case now of putting the let's get rid of all these meters everywhere. These, got to get these put back in. So let's use the old manual solder sucker for this, if I can find it. Cheers, Brett. So hopefully you could see everything there. So that's our test point there, so we need to suck that off. Let's just unplug this, it's going to make it a damn sight easier. Then I think we'll plug it all back in and we'll stick it together and give it a test. So we've got that one there to desolder. Where's the other one? The other one is in here. Cool, there's a load of solder in that one. They poured down, they stuck half a reel down there, I think. There we are. So just got to poke these wires back down through them holes using my forceps, which have once again disappeared. I think that's the one tool that seems to disappear the most, is the forceps. I don't know why, it just does, it's a pain. I don't know whether I put them back, that's why. I can't tidy myself up. This is a problem. Don't tidy yourself up because you'll lose everything. Get back in there, you monkey. That one and this one. They certainly used a fair bit of wire on these. Right, let's get them soldered back up. It's that one. That one. Smells of nail varnish in here. Let's make sure that they're definitely soldered. Yep. Yeah, good, right. Let's get it back together. As I say, it's got to be restored properly yet. It's got to go right the way over it and give it a good clean, etc., etc. Oh, I need to sort this one out, don't I? Let me just do that. I need to take my link out as well. You didn't tell me, did you? You were just waiting for me to fail. Come on, what's going on here? You think you are? Just because you're bipolar? Right, I'm just going to swap that around so it's the other way around, just to keep it away from that plug, that's all. That's all. It's not going to hold now, is it? No. It's just going to drop right out. I shouldn't say it, should I? And it wouldn't happen then. I'm just tempting fate, really. Right, God, it does smell of nail varnish in here. Mrs. Crunch will think I've been painting my nails. She won't know it's hers. Better. Right. As I was. Get these washers out of the way. Pop them back on there for now. Yeah, it looks like it's broken, doesn't it, Theo? Afternoon, Bill. How are you, mate? 72. Excellent. It's the big finale now. Will it or won't it work? Because we haven't tested the... we can't test it. We can't. Because the ferret is all cut off. I've cut the ferret off, haven't I? No, it's just a little bit too... I might be able to get a signal in with a wire. We'll try. I'm not going to reconnect the ferret today. Not today. Not today. Because I've got to go down and keep Mrs. Cruncher company. She's not very happy. She's a bit upset about the whole water situation, which you can't blame her. The whole leaking drains situation under the house. Just wondering if I can get an antenna across here. I might be able to. So we can give it a test. Or we could go in the canal, because that's a coil around there as well. I'm not sure which two are which. We'll see if we can get a signal into it. So I'm not holding up much hope. Dee, 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 dee. A quick look how is it possible to hook this up temporarily. So what's that there? What's that there? So that's long wave, that's medium wave. So medium wave is the one we want connected up really. It's red, black and blue. Sod it, let's do it. Let's do it. Yeah. Graham, doesn't swiveling the capacitor around have any effect? Plus, minus, reversal. No, it's a bipolar one, that one, Ben. It's a bipolar cap, so that's one of the quirks of this particular circuit board. An amplifier, it uses these 8 microfarad bipolar caps. So it's non-polarized, so if you see the end is crimped at both sides. So it's non-polarized, and the one that came out of it was marked reversible, so also bipolar. I'm just going to see if I can tack this ferrite back on for a minute. Just for a quick test. God, it's typical, isn't it? Whenever you're in a hurry, it's always going to take you longer. Less haste, more speed, isn't it? Or something like that, they say. He says, crunching the veins of the tuning cap as he goes. God. So I'm just going to connect up the medium wave now. There's no point connecting long wave because there's nothing apart from radio 4 on long wave. So let's do the hardest one first, and the others will be easy, won't they? Fire in the hole. Fire up. So black goes on there. Blue goes there. Right, that's the medium wave coil hooked back up. It's a bit precarious. Probably on upside down, but should be good enough for us to test it. Right. We'll get the external antenna in, give it half a chance. Let's turn it on to medium wave, which is that one. How are we going to do this?
Resumed, but going back to
it's working.
It's because Milner's not getting closer to him now. And you called it in the first half. Milner was really right up tight. Kante wasn't really getting involved as much. Now Kante's putting the feelers on Milner and really starting to dominate the midfield of the back.
3 took the selfie, 10 yards inside their own half. So 2-2 the score. Liverpool were 2-0 up, Mane and Salah. And then Kovacic and Pulisic scoring twice in 3 minutes at the end of the first half, and thrillingly so as well. You need to see that on Match of the Day.
Sorted.
Read about it on the BBC Sport website and app.
There we are. I'm going to disconnect that because that ferrite rod is just floating around there at the moment. It's fixed, but it's just floating in air. It needs reconnecting to the terminals there. So there we are. That's it. It's done. What a game that was. I thought that would be a quick job, that. I thought that would be a quick job. Right, let's catch up with the chat a minute. Simon's sorted that. Are you sure your pipe isn't just blocked and not damaged? No, it's emptied the water out on the underneath the floor, Spanky. Thanks for that, Simon. So bipolar electrolytic is 2 electrolytic caps in series with the positive to negative joined. Magic smoke, no magic smoke, luckily. I Dom. There we go. Yeah, it's typical, isn't it? There's me thinking that would be I'd be struggling to struggling and have to do the alignment and everything as well, but just the amplifier's taking up the whole stream. So there you are. 2022 flooded floor, amplifier fixed. Anyway, I will keep you updated on the situation with the sewage underneath the downstairs floor. It's not sewage, it's wastewater, isn't it? What they used to call grey water in the caravan in circles. So that's it for now, people. Thanks to those, I think it's mainly Rob Cross for the super chats. Thank you very much again, Rob. Much appreciated. With your little picture of your doggy. And I have got a new Patreon. Mr. Videolan has now joined my band of Patreons, so thank you very much, Videolan. Not seen you in there today, but welcome. And you did win. What did you win? I think you won the kits, didn't you, Videolan? I can't remember. You did win something or other, but thanks very much for joining. I think it's Lawrence, isn't it? So thanks very much for joining me. That's it for today. There'll be bits and pieces in the week on Patreon, but other than that, I'll see you next Sunday. Seems weird not being on every day, doesn't it? Very strange. Anyway, bye all. Thanks for joining me, and catch you again soon. And I'll play it to the old credits that say 2020. See if you can spot them. If I can get them up on screen, that is. Anyway, thanks again for joining me today, people, and catch you again soon. Bye for now.